ready to the countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by eDidik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Good evening, teachers, parents, and all the wonderful students. Welcome to Pusat Academy YouTuber, Bermula Percuma, Selamanya Percuma. How are you doing today? I hope all of you are ready for today's lesson. Before we proceed, let's begin our session by reciting a prayer according to your own religion. Let me introduce myself. I'm Teacher Tan from College Matriculasi Selangor, the moderator of the day. We at the Pusat Academy YouTuber will provide you with free online classes. So let's take this opportunity to do your revision. So are you ready? Let me introduce our teacher for today's lesson. We have Teacher Kon from College Matriculasi Perak. We are now live on Teacher Kon's channel. Please support her channel by clicking subscribe now. The topic of today's lesson is all about thermochemistry and electrochemistry. And together with us, we also have Teacher Bibi Lau from Pusat Tingkatan 6 SMK Tinggi Klang, who is the control host to ensure the smoothness of our lesson on technical support, and Cikgu Mawar from KPM as the observer to ensure the smoothness of our lesson. So before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Stop chatting and use the chat sessions wisely. Number two, regarding certificate link, the link will be given at the end of our session. Please use your eDidik account when you fill in your particulars. And make sure to listen to the passcode given by me throughout the lesson and fill in the form within the time limit, which is 30 minutes. Before starting the class, I shall give you the first two class codes, which are A2, A2, A2. So without further ado, let's welcome Teacher Kon. Teacher Kon. Teacher Kon, okay.
Clear?
Clear. Just now you muted your mic. Okay, clear now. Teacher Kon?
Okay.
Yeah. We can hear
Teacher
you.
Ta? Okay. So this is my team. So here, okay, so Cikgu Shanun is our leader. Okay, there are Teacher Bibi Lau, okay, as control host today, Teacher Tang as moderator, and Cikgu Mawar as the observer today. Okay, besides pre-U chemistry team, right? Okay, next is mathematics team, who lead by Teacher Im. Okay, next is biology team, okay, who lead by Cikgu Faiza. And then next, physics team, who lead by Madam Rosmaya. Economy and accounting, who lead by Madam Fizi. So this is our tuition online every Sunday, 3:30 p.m. So please stay tuned with us. And then this is my personal profile. I'm from Perak Matriculation College. I have around 11 years of experience in teaching chemistry. So please do remember, subscribe my channel and like and share this video. Okay, so today's topic, right, is about thermochemistry and electrochemistry. Okay, so before we start, right, okay, let's check the overview for thermochemistry. Okay, for thermochemistry, right, there are 4 subtopics. Okay, the first one is about concept of enthalpy. And then number 2 is calorimetry. Number 3 is Haslov. And number 4 is Born-Haber cycle. So we have a quick review for each of the subtopic and try one question for each of the subtopic. Okay, so first of all, right, for concept of enthalpy, we should know what is energy profile diagram. So there are two, exothermic reaction and endothermic reaction. Okay, before we proceed with the energy profile diagram, right, you should know, okay, for exothermic, we must have the concept, right? It is heat release, okay? Heat release, okay? And then with the enthalpy value, negative value. Okay, of course, endothermic, heat absorb, okay? Heat absorb. So, okay, the enthalpy value normally is, for sure, okay, 100% is positive value. Okay, so now we check for both energy profile diagram. Okay, you try to observe what is the difference between these two energy profile diagrams. Okay, the similarity is we must label for the y-axis potential energy and then label for the x-axis progress of reaction. Okay, for sure we have to label for the activation energy, the EA forward, okay, the enthalpy, EA reverse. Same for here, EA forward, EA reverse, and the enthalpy. Okay, and then we must show the reactants, product, reactant, product. So what are the difference or what is the difference between these two energy profile diagram? Okay, the difference, right, is the enthalpy of the difference of enthalpy for the reactant and product. The enthalpy of reactant is higher than the enthalpy of product for exothermic. While for this one, right, the enthalpy of product is higher than the enthalpy of reactants. So here is the difference of the enthalpy. Okay, so normally, right, I will guide my student, right, you just try to label, just put a value. Okay, this is 1, this is 2. Normally, right, we are using the final enthalpy minus the initial. So this one, 1 minus 2, you get -1. Okay, negative value. So this is, okay, exothermic reaction. Okay, for this one is 1, this one is 2. So 2 minus 1, you get positive 1, positive value. So this is endothermic energy, endothermic reaction. This energy profile diagram is showing this is endothermic reaction. Okay, so I hope you all won't confuse between these two diagrams. Okay, now let's try to do one question about energy profile diagram. So based on this given equation, right? Okay, this one normally you call this is chemical equation, but when enthalpy is given, we call it as thermochemical equation. Thermochemical equation. So must always remember if the question asks you to write down the thermochemical equation, right? You must make sure you write the balanced chemical equation and then come together with the enthalpy value. Okay, positive and negative sign insists if exothermic negative, endothermic positive, and then must with the unit. Okay, so now we try to check. Okay, yeah, you must know here is the reactant, here is the product, and then this is endothermic exothermic reaction. Okay, so there are 3 questions. First, sketch. Okay, if the keywords with sketch, right, you just need to sketch, no need to use the graph paper. You just sketch the energy profile diagram for the above reaction. And then second question, which enthalpy is larger? So you can answer either is reactant or product. So based on here, this is exothermic reaction. Okay, if you're not clear, no worry, you can check from the energy profile diagram. Okay, and then the third question, right? What is the enthalpy change under the same condition? Okay, did you notice something? Here, 2 mole, 2 mole. Here, 1 mole. Okay, and then one more thing, right? Just now here, our reactants now become the hydrogen and oxygen become product. So meaning that for this equation reverse, to sketch an diagram, right, I'm using the previous diagram. Okay, but can react and product. What we are going to do, right, we have to show the reactant based on the equation. Okay, for here, hydrogen gas, half oxygen gas, okay, are the reactant, so you must follow exactly. Phase insists, and then is product, H2O gas. Okay, and then the enthalpy given here is negative 241.8 kilojoule. So you must write out the enthalpy. You cannot just mention its negative value. Okay, because this question, right, EA forward and EA reverse is not given, so you can just label it in generally. Okay, if the EA forward or EA reverse are given, right, you have to label as well. So this is the energy profile diagram for the above reaction. So this is the answer A. Okay, and then you check here. Okay, if you compare both enthalpy, right? Okay, larger enthalpy for the reactants. So that's why right, the answer for B right is reactants. Okay, reactant has larger enthalpy. Okay, so this one as I mentioned right, okay, have to reverse and times 2. That's why right, okay, initially it's with negative 241.8 kilojoule. After reverse it will become positive. And then please do remember times 2. Of course you have to show okay the calculation and then the final answer with the positive sign and the unit kilojoule. Okay, so this is the answer for this question. Okay, just have to. Okay, I give you 2 to 3, 5 seconds. Okay, we check everything. Okay, make sure right you label for the x, the y and x-axis. Okay, meaning that here I forget for the x-axis, so you have to write down progress of reaction or reaction pathway. Okay, progress of reaction. Okay, you have to write down for the x-axis as well. Okay, must label for the x and y-axis. Okay. Okay, and then must label for the reactants, products, and then the enthalpy value. Okay, make sure that okay because for exothermic right the enthalpy of reactant is higher. Okay, as I mentioned just now right you can put the value 1, 2. Okay, 1, 2. So 1 minus 2 equal to negative 1. Okay. So this is just example to help you if you feel oh nervous, confused, you don't know how to plot the energy profile diagram. You're not sure which one is higher, which one is lower. You can try to substitute. Okay, just a simple value to make yourself clear. Okay. Now next. Okay, concept of enthalpy involves few definition. Okay, we must okay, student always confused. Okay, when all mixed together, right, still confused, not sure. Okay, enthalpy formation, enthalpy of hydration, we mix all. Okay, now we try to check one by one. So for here, right? Okay, so formation right is referred to heat change when one mole of a compound is formed from its element in their most stable at stated temperature and pressure. Because this one just enthalpy, not standard, so that's why right we define it as most stable at stated temperature and pressure. So we check for one thermochemical equation. So you have to always remember for enthalpy of formation is referred to the product. Okay, because based on the definition, one mole of a compound is formed from its element. Here, again, make sure right you have to label the phase for each of the compound. Okay, next. Enthalpy of solution or enthalpy of dissolution actually is the same thing. Okay, heat change when one mole of substance is dissolved in water. Okay, so if you check for the thermochemical equation, meaning that this is referred to reactants because according to the definition, right, one mole of substance is dissolved in water. Okay, and then to form a value dilute solution at stated temperature, so it's referred to potassium chloride. Okay, normally it's involve ionic crystal. Okay, next. Hydration. Okay, it's the heat released when one mole of gaseous ion is hydrated in water. So one mole of gaseous ion, after hydrated in water, it will become aqueous ion. Okay, so in this case, it's referred to the aqueous gaseous ion. So one mole of gaseous ion dissolved in water from the aqueous ion. Okay, must one mole because if you check 3 definition, all it started with heat change, and then one mole. Okay, and then combustion is referred to heat release. Okay, now you notice right why I put the negative sign here, because when heat release is exothermic reaction. Sign right, enthalpy right, negative value. Okay, one mole of substance is burned completely in excess of oxygen. So this one is referred to the reactant methane because methane right react with excess oxygen and then form the product. Normally combustion right the product is CO2 and H2O if excess oxygen. If limited or very limited right then it will become carbon monoxide or carbon dioxide. Okay, so again you see negative 802 because heat release exothermic reaction. Okay, neutralization is referred to heat release when one mole of water is formed. From neutralization of acid and base, you will check for this equation, right? Okay, is acid, hydrochloric acid react with sodium hydroxide and then form sodium chloride and water. So for this definition is referred to water. Okay, one mole of water is formed from the neutralization between acid and base. Okay, atomization is the heat absorbed when one mole of gaseous atom is formed from its element. Okay, one mole of gaseous atom is formed. Is formed, meaning that this is referred to the product. Okay, gaseous atom is from its element. Okay, so these are the six enthalpy that we need to know. Besides that, we have to know what is ionization energy, what is electron affinity. Okay, both of them is opposite. Okay, ionization is energy is required to remove electron, while electron affinity is energy changed to add one mole of electron. Okay, so you see this one. Okay, is the gaseous atom. Okay, after remove electron, it form the gaseous ion, and this one also gaseous atom. Okay, after added electron, it form an ion. Okay, we also must know what is lattice energy. Okay, there are two. One is lattice energy of formation, and the one is lattice energy of dissociation. But we more focus on lattice energy of formation. So energy release. So based on this definition, right, you know, lattice energy formation is exothermic reaction. So if lattice energy of dissociation, it will be the opposite one, means it's energy absorbed. Okay, if dissociation, energy absorbed. So in this case, okay, the sign will be reversed. Okay, so we have to always remember, if the equation reverse, then the enthalpy sign need to be reversed. And then if the equation times 2, then the enthalpy value need to times 2 as well. Okay. And then if standard enthalpy is referred to, okay, the enthalpy change for a particular reaction occur at 298 Kelvin, means 25 degrees Celsius and 1 atm. Okay, there is a formula that we are going to, we are always applying to calculate the enthalpy of reaction. We are using the sum of the enthalpy of formation of product minus the sum of the enthalpy of reactant. So this one is the overview of the concept of enthalpy. Okay, why I revise this one with you all, because we are going to use the concept of enthalpy to apply for the dissolution process and Born-Haber cycle, okay, in the form of cycle or an energy level diagram. So this part is very important to assist you to answer the question related with dissolution process and Born-Haber cycle. Okay. Okay, next we move on to calorimetry. Okay, so we must know, okay, for calorimetry, right, it works two important definition, which are specific heat capacity, okay, small c, is the amount of heat required to raise the temperature of 1 gram of substance by 1 degree Celsius. Okay, we check. So, because it involves an energy, right, okay, and enthalpy, right, so the unit must involve joule. Okay, joule is the amount of heat, okay, required. Okay, you see why per gram? Because we need to raise 1 gram of substance, okay, and then why per degree Celsius? Because, okay, by 1 degree Celsius. So the difference between specific capacity and heat capacity, right, okay, is this one is any amount. For heat capacity is raise the temperature of a given quantity, means any amount of the substance by 1 degree Celsius. So the difference between these two, right, you check, okay, this one joule per gram per degree Celsius, but for heat capacity is joule per degree Celsius. Okay, to answer the question related with calorimeter, here it will few steps. Okay, normally I will guide my student, right? Okay, step 1, write a balanced chemical equation. Actually, it depends on the question. If the for certain time, right, okay, we don't need to write a chemical equation, we also can answer the question. But since to avoid you lose mark, right, okay, you just try to practice these few steps, because if you answer extra, the mark won't be deducted. Okay, so you try to follow the few steps, okay, and then number 2, normally we need to calculate the number of mole, because given quantity we always refer to number of mole, even though the question given in gram, we have to calculate the number of mole of the substance by divided the molar mass. Okay, step 3, identify the heat change, then choose a formula. Okay, how to identify the heat change, how to identify which formula we are going to apply. Okay, I will guide you all later. And then compare by using stoichiometry method. Okay, answer the question accordingly and make conclusion. Okay, make sure that the final answer must be correct. Okay, this is the formula. Okay, step 3, identify the heat change, then choose a formula. Okay, normally the basic principle in calorimeter, right, involves heat released by a reaction, then heat absorbed by surrounding. The surrounding might be solution or calorimeter. Okay, if only involves calorimeter itself, right, the formula that we are going to use is heat capacity times the delta T. Okay, if involve water and calorimeter, then the heat released by the reaction, right? Okay, we have to calculate the heat absorbed by the water, means using MC delta. Okay, delta means delta T and C delta T. Okay, and only the water itself, right? Then MC delta T. If you want two different solution, right? Okay, and then MC delta T plus MC delta T. Here. So again, if you're not sure what is Q, Q is referred to heat released by reaction. Okay, in any amount. M is mass. Okay, W is referred to mass of water. Okay, small c is referred to specific capacity of water. Capital C is referred to heat capacity of calorimeter. And delta T is referred to the temperature change. Okay, let's try one question. Okay, so based on here, right? Okay, this is mass. Okay, we must know. So this is mass given by the question. This is mass of hydrogen. Okay, and then 1 liter of both and placed into a calorimeter with heat capacity. So this is capital C. Okay, with this value 9.08 times 10 to the power of 4 joule per degree Celsius. Okay, this is T initial 25, and then this one is T final. So delta T, so T equal to T final minus T initial. Okay, calculate the amount of heat released in the reaction to form water. Okay, in 1 mole. Okay, because here, right, just 0.1 gram of water, hydrogen. So 1 mole, okay, for this part, right, we are going to solve by using step 4, compare by using stoichiometry method. Okay, now try step by step. Write a balanced equation. Because here we know this is the reaction between hydrogen gas and oxygen gas and then form water. Okay, so the equation, hydrogen gas react with half oxygen gas and then form water. Okay, normally we need to determine the limiting reactant. In this case, it's very clear. Why? Because given the hints, excess oxygen. Okay, excess oxygen. So we know, right, hydrogen is the limiting reactant, and then all the mole, right, we just refer to this one, 0.1 gram of hydrogen gas. So step 2, okay, we are going to calculate the N of hydrogen by using 0.2 divided by 2. Why? Okay, because hydrogen gas 3 atom. Okay, many of the students, right, they will 0.1 divided by 1 because they forgot already. Hydrogen gas is at H2. This question is quite clear because the molecular formula H2 is given. If it's given in wording hydrogen, okay, many of the students just assume it's H. So this one is wrong. Hydrogen gas is 3 atoms, so H2. So that is 0.05 mole. Okay, next, identify the heat change, then choose a formula. So for this case, right, involve bohm calorimeter, okay, and place in calorimeter, okay, and then involve. Is it involve water? No. Involve heat calorimeter. So we just city times. So we're using Q equal to C delta T. So C is given delta T. Okay, it's using 25.155 minus 25, and then you get 0.155 degrees Celsius. Okay, so here okay, maybe some of you might put negative. Yeah, because it's heat release. So you can put like negative. Okay, if you didn't put negative, it's fine. For this case, okay, we just remember we have to make the conclusion. Okay, in this case, heat release. Okay, if you put negative, 14.074 kilojoule. Okay, here is heat release, so it's negative Q equals to C delta T, and then at last, right, it's negative 14.074 kilojoule. Okay, also can. Okay, next, compare. Why? Because the heat release, right, this one, right, is from 0.05 mole of hydrogen gas. Here, stoichiometry is 1 to 1. Okay, 1. So 0.05 mole of water actually is equal to 0.05 mole, 0.05 mole of hydrogen, 0.05 mole of water as well. So now the question asks about, so what happened? So we can settle the problem, solve the problem, right, by stoichiometry comparison. Okay, yeah, 0.05 mole water equal to this. Okay, 1 mole, you just stoichiometric comparison, okay, you get 281.48 kilojoule. Okay, so always stick to the stoichiometry method. So now last, the conclusion. So this is what I mentioned. Make sure that the final answer, right, must be correct unit and then the negative sign. Okay, must with the negative sign. Okay, if not, right, you have to put the negative sign over here because this is a heat release. Okay, here the release is referred to exothermic. So that's why, right, the answer must be the negative sign. So the last one, okay, make the conclusion. Heat of reaction is the enthalpy of the formation of water, right, is negative 281 kilojoule per mole. Okay. Or everyone of you read and then know how to solve the problem. Just follow these 5 steps. Okay. So next is about Hess law. Hess law is the reactants are converted to product. Okay, and then the change in enthalpy is the same whether the reaction takes place in one step or in a series of steps. Okay, so this is one of the example. Okay, let's try to solve the question by using Hess law. Okay, so this is okay. Before we continue, right, we must know which one is the targeted equation. Okay, so hydrazine is used as a rocket fuel since its reaction with oxygen is extremely exothermic. So this is one of the equation. Okay, calculate enthalpy reaction with liquid water is produced. Okay, you check the hints here. Liquid water. Okay, liquid water is produced instead of steam. So meaning that, okay, the targeted equation is this one. So this one is the targeted equation. Okay, then we are going to use this equation 1, equation 2, okay, to produce this targeted equation. Here, so for here, right, there are 2 methods. One is algebraic method, another one is energy cycle method. So I straight away to show you all the algebraic method. Okay, so this is algebraic method. So this is what I say, this one is the targeted equation. So this one is the targeted equation. This is targeted equation. Okay, I should write down T. I label it as T. So this is the targeted equation. Okay, and then next, okay, this one, you see, hydrazine, right, react with oxygen and then form nitrogen gas and water. Oh, no, water. Actually, this one is steam because in gas. So this one is equation 1. Okay, this one is targeted equation. And then from the nitrogen gas react with water. Okay, nitrogen gas react with water, gas. Okay, and then form this one, nitrogen gas and water. Okay, over here, right, this is the enthalpy too, isn't it? Let's check. Okay, here, this one, right, you see nitrogen gas here. Okay, so me for this equation, right, okay, reverse already. This equation is reverse already, isn't it? Check out water. Oh, I think I copy and paste problem. Okay, due to copy and paste problem. Check nitrogen, form nitrogen gas, and then plus water, and then form NH4, N2H4, N2H4, liquid 40 point. Okay, I think something wrong from here. So, okay, something wrong from here. Okay, never mind. We check for the energy cycle method is much more easier. Okay, because this question I didn't mention we need to use algebraic method or energy cycle method. So both acceptable. Acceptable. Okay, I prefer using energy cycle method. Okay, this one, because this one, right? Okay, here not supposed to put the oxygen gas because oxygen show over here. Okay, this one is the first equation, N2H4 liquids plus oxygen and then from nitrogen plus 2 water. So this is enthalpy 1. So this is the enthalpy 1, negative 534 kilojoule. After that, right, this nitrogen gas plus 2 water, okay, 2 mole of water gas, okay, 2 mole of water gas, okay. Sorry, I also a bit confused because this one is 40. So this one, right, okay, suppose it's water. Okay, later I will share you all this answer again for the algebraic method. We move to this one. Okay, energy cycle method. I prefer using this one because as I say, I want to find the targeted equation and then I list out the enthalpy 1, enthalpy 2. Okay, for this case, right, okay, I try to check, okay, this is, why I circle these 4 compound? Because I know this is a targeted equation. I need 1, 2, 3, 4. I need these 4 compound. After that, I have to ensure, right, the number of mole for this compound, right, is tally. Okay, so you check this water in liquid form over here, right, is reactant. But what I want, right, is in product, meaning that this equation need to reverse. And then here there are 2 mole, here only 1 mole, so I need to times 2. But for the enthalpy one, right, you see, still the same. Reactant, 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 reactant. And then this one, product, product. Okay, so I have to rewrite everything. Okay, after I rewrite everything, right, so this is enthalpy 1 with negative 534 kilojoule. And then the second one, I reverse, right? Reverse, initially is positive, now become negative. After time 2 is 81.4 kilojoule. So I circle the reactant and the product that I want, and then I cancel off the rest. Okay, 2 water, cancel off. And then, yeah, I success to get the targeted equation. So this is the targeted equation. Okay, after that, don't forget, right, you have to show the calculation for enthalpy reaction equal to enthalpy 1 plus enthalpy 2. So you get the answer negative 615.4 kilojoule. Okay, so sometimes, right, the student will confuse. Okay, they're not sure how to use the algebraic method. Even myself, I also get confused by using algebraic method. So no worry, you can try another method and then you try and check the algebraic method for one more time. Okay.
Teacher
Okay,
Kon,
next is about these solutions. Yes.
Teacher Kon, can we stop for a while
Yes.
for the advertisement?
Yeah. Okay. Thank you, Teacher Tang.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Before we continue with the class, let me give you the third and the fourth passcode. So the third and the fourth passcode are 6, 5, 6 and 5. So the third and the fourth passcode is 6 and 5. Okay. So Teacher Kon, you may continue the class.
Okay, thank you, Teacher Tang. Okay, welcome back. So now we move on to the solution process of ionic crystal. For this topic, right, there are a few enthalpy that we need to know, as I explained just now, right, involve lattice energy. Okay, here showing dissociation, but I prefer lattice energy of formation. Later I show you all heat of hydration and heat of solution. So try to check for this question. Okay, so enthalpy of hydration of sodium, enthalpy of hydration of chlorine, ion, and enthalpy of solution of sodium chloride are given. So let's try to construct the energy cycle diagram and calculate the lattice energy of sodium chloride. Okay. So first of all, right, okay, we must know how to form the equation, the thermochemical equation, okay, based on the enthalpy given. So this one is the enthalpy of hydration of sodium. So we must know, right, okay, according to definition, hydration is a heat release when 1 mole of gaseous ion is hydrated in water. So this is the 1 mole of gaseous ion hydrated in water from the aqueous ion. Okay, same for here, the chlorine. And then this one is the enthalpy of solution. 1 mole of substance dissolved in water to form the aqueous ion. And then the lattice energy, right, okay, I will refer to the lattice energy of formation. So it's the gaseous ion, okay, and then from the sodium chloride crystal solid. Okay, so this is the lattice energy of formation. So for here, right, I will start with the lattice enthalpy of solution first. Okay, so this is the sodium chloride solid, okay, and then sodium aqueous and then chlorine aqueous is formed. Then next, hydration. Hydration is a gaseous ion hydrated in water to form the gaseous aqueous ion. Okay. Please to remember, must label the enthalpy of hydration of sodium ion and then with the enthalpy value negative 390 kilojoule. And then chlorine enthalpy of chloride ion negative 380 kilojoule. Okay, and then the next, right? Okay, here is the lattice energy of formation. Lattice energy of formation of sodium chloride. Okay, now we try to find the relationship based on this energy cycle diagram. So you notice right here is the final destination. So okay, and then we know, right, the enthalpy of lattice energy formation plus the enthalpy of solution, right? Okay, equal to the enthalpy of hydration of sodium ion plus the enthalpy of hydration of chloride ion. Okay, we are applying the concept of vector that we learned in physics and mathematics. So now what is the enthalpy of lattice energy? So is equal to negative 390 plus negative 380. Okay, here positive change to here become negative. Okay, plus 6 kilojoules, so you get negative 776 kilojoule per mole. This is one of the method, okay, based on the definition. If you solve the problem according to definition. But if you are using this diagram, right, okay, the diagram here, right, showing that, okay, lattice energy of dissociation. So another method, right, okay, we can do like this. Because since, okay, we are, okay, so you can, according to this one, okay, over here, right, initially is positive 6. Given here is positive 6. Positive 6 is enthalpy of solution. So enthalpy of solution is referred to, okay, 1 mole of substance dissolved in water. If you're doing the reverse one, okay, if doing the reverse one, yeah, no problem. But you have to remember, change the sign, become negative. So for this case, right, the final destination is here. Okay, sodium chloride. So we check. Now is the enthalpy of lattice energy equal to this sum up from these three enthalpy. So that's why enthalpy of hydration plus enthalpy of hydration of chlorine plus the enthalpy of solution, which is negative 6. Okay, you get the same answer. Okay, you get the same answer. So I prefer, right, my student, okay, remember the understand the concept of the definition and then form according to the definition. Also no problem. Okay, next is about Broad-Table cycle. Okay, this one last week, okay, Cikgu Teacher Shannon, right, got teach you all about this one. F, okay, F is refer formation, A atomization, A atomization. After that is I, and then E, L. Okay, I is referred to ionization. Okay, E is referred to electroaffinity, and then L is referred to lattice energy. So I just have a quick revision with you all because last week teacher Sir Shannon got teach you already. So mass from the sodium potassium chloride crystalline solid, right? Mass from its element, so potassium solid, and then chlorine gas. So make sure, right, is 1 mole of gaseous ion is formed. 1 mole of gaseous ion is formed from the enthalpy of from the atomization process. After that, this one remove 1 electron, so ionization energy, potassium ion. And this one 1 mole of electron is added, become chlorine negative ion. Okay, and then gaseous ion form and then form the crystallized potassium chloride potassium chloride solid, ionic solid. So this is, now we need to calculate the enthalpy of lattice energy. So as I say just now, right, according to vector concept, right, you see here is the final destination. So the enthalpy of formation, right, is equal to enthalpy 1, enthalpy 2, enthalpy 3, enthalpy 4 plus enthalpy 5. So and then 5 equal to, okay, formation minus 1, 2, 3, 4. So the lattice energy equal to negative 701 kilojoule per mole. Okay, so this is what I say. So enthalpy of formation equal to 1, 2, 3, 4, 5. So 5 equal to formation minus 1, 2, 3, 4. Yeah. Okay, now we move on to part 2, electrochemistry. So electrochemistry, there are 3 parts. The first part is involve galvanic cell. Second part is Nernst equation. Third part is electrolytic cell. Okay. Okay, for the first part, right, normally we'll involve the formula E naught cell equal to E naught cathode minus E naught anode. And then the second part, we will involve the Nernst equation. So this one is the Nernst equation. We must know what is log Q. Q is the concentration of product over concentration of reactant. And then don't forget the stoichiometry, the power. Okay, the power is according to the stoichiometry of the overall equation. Okay, for part 3, involve Q equal to IT. Q is referred to electrical charge in coulomb. I is current in ampere. Time in second. Time must in second. If given in hour, minute, you must change to second. And then involve Faraday constant. Okay, which is 1 Faraday equal to 96,500 coulomb. Okay, look at this question. Predict whether the following reaction occurs spontaneous or non-spontaneous. Okay, actually, right, this question is quite simple. As long as you calculate the E naught cell, if you get the E naught cell equal to positive, okay, E naught cell equal to positive, then spontaneous. If you get the E naught cell equal to negative value, then it's non-spontaneous. But first of all, you must know, identify the anode and cathode. So for this case, because oxidation number of zinc, right, increase from 0 to positive 2, so this is oxidation. Automatically, another one, double check, is it reduction? Yeah. So this is reduction. Okay. So now you know, right? Okay, zinc is anode and cathode is stannum. Method 1 or method 2, up to you. So I'm showing both. Okay. So the first one, right? Okay, I'm using the E naught cathode minus E naught anode. So sub the value. Okay, because value is given here, you just sub the value. Straight away use that value. Okay, and then you check. Okay, get positive 0.91 volt. So positive sign insists, unit insists. So you know this is spontaneous reaction. This is method 1. Okay, if method 2, right? Okay, we have to be careful for the reduction, for the standard reduction potential for anode. Why? Because this equation changed already. Initially, the standard reduction equation should be like this. Okay, solid. First, don't forget the phase. So the value, right? Okay, based on here is the E naught. Okay, the E naught reduction is negative 0.76 volt. Since the equation is reversed, so the sign has to change. Okay, become positive. Okay, this one remains the same because still standard reduction, still in reduction form. Okay, then we try to apply the formula E naught cell equal to E naught reduction plus E naught oxidation. Actually, you can sum over here. You can sum over here and straight away get the answer E naught cell equal to positive 0.91 volt. But you must write down the formula as well. Okay, because normally formula or substitution, right, might give you 1 mark. Okay, and then you get the same answer as well. Okay, so positive sign, so spontaneous reaction. So the question if I ask you why is spontaneous reaction? Because the E naught cell greater than 0. Okay, the E naught cell is greater than 0, so this is spontaneous reaction. Second question. This one is part 2 involvedness equation. So, okay, I highlight already. So this is anode, okay, it's lead, nitrate, okay, cathode, hydrogen gas. Okay, the concentration of the lead nitrate is 1 molar. The pressure of hydrogen, right, is 1 atm. And then the constant of the hydrogen 0.3 times 10 to the power of negative 5 molar. So first question, write the cell notation. Second question, calculate the cell potential. E cell, this one have to apply the Nernst equation, but before that, we also have to calculate the E naught cell as well. And then again, predict spontaneity of the reaction. Okay, so based on here, right? Okay, we try to write down the cell notation. Okay, before I write the cell notation, right, I will encourage my student write the equation for anode and cathode. So anode, what happened? For anode, right? Okay, undergo oxidation. So Pb solid. Okay, and then form Pb2 plus ion. Okay, plus 2 electron. And then for the cathode, right? Okay, for the cathode is undergo reduction, 2 plus aqueous ion. Okay, and then plus 2 electron from the hydrogen gas. Okay, so you just combine the overall equation. So you get Pb solid plus 2 hydrogen gas aqueous, and then form Pb2 plus aqueous ion, and then plus hydrogen gas. Okay, since the number of electrons is the same, that's why no need to balance. So this is the overall equation. This overall equation, even though didn't ask by the question, right, I will encourage my student to do this step. Okay, because right, second part, cell potential E cell. So this E cell, right, we need to refer to overall equation. That's why I will ask my student, right, to write down anode and cathode and overall equation, even though didn't ask by the question. Huh? Okay, now we proceed with the first question, cell notation, right? The formula for cell notation, we start with anode first, and then cathode. Okay, so I straight away show you the answer. Okay, here, anode, Pb solid, right? Okay, we do oxidize, some Pb2 plus, must show the phase and the concentration. Okay, this refer to the salt bridge. Okay, salt bridge. Okay, refer to two different solution. Hydrogen gas in aqueous 1.3 10 to the power of negative 1 molar, and then form hydrogen gas. Okay, this is platinum using platinum so electrode. Okay, so this is the first answer. Okay, and then next you have to show the why you need to calculate the E node cell, because according to the formula here, right? Okay, according to the formula here, E node cell minus 0.0592 over n. So that's why we have to calculate the E node cell first. So E node cell, okay, the cathode is hydrogen, cathode, yeah, hydrogen 0.0, and then the E node anode is the lead, okay, so minus negative 0.13, which given by the question, here you see, given by the question. Okay, given by the question. So you apply the formula E node cathode minus E node anode. Okay, substitute and get the answer. Okay, this is the overall equation. Okay, this is the reason why just now I showed you all. You must write down the overall equation. How the overall equation come from? From the anode half cell and cathode half cell. Okay, so based on here, right? Okay, the concentration of product. This is log Q. Concentration of product Pb2 plus, and then this one gases. That's why P pressure of hydrogen over the concentration of hydrogen ion, okay, to the power of 2, and then ignore solid, so you just sub all the value, okay, you just sub all the value here, positive 0.13, okay, why 2? Because why the n is equal to 2 here, 2 electron, so that's why the n is equal to 2, and then the log, okay, you just sub everything, okay, you just sub everything. So please be careful when you sub, right? You must be double check, okay? The concentration of the Pb lead ion is 1 molar, and then the pressure of the hydrogen gas 1 atm, and then the concentration of the ion is 1.3 times 10 to the power of negative 5 molar. Okay, and then you get the answer. Okay, please practice how to press the calculator. Okay, and then you get the E cell equal to negative 0.16 volt. Okay, so this is non-spontaneous reaction. This is non-spontaneous reaction. Okay, part 3 for the electrolytic cell. Okay, so involve copper sulfate solution and then 0.15 ampere for 5 hours. This is what I mentioned just now. Because, right, we need to calculate the Q equal to IT. Okay, this is the I. And then this one is the T. T must in second. So 5 times 60, you just convert into minutes. That's why you have to time one more time so it can convert to second. Okay, and then calculate the mass of a copper deposited at the cathode. Okay, at the cathode. Cathode over here, right, is involved copper. Okay, so in this case, first Q equal to IT. So Q equal to ITI is 0.15 times 5 times 60 times 60. So this is the first step. So you press the calculator, you will get 2,700 column. Okay, second step, I will write down the equation. So Cu2 plus aqueous ion plus 2 electron and then form copper solid. So from here, right, okay, I know 2 electron is equivalent to 2 Faraday. So 1 Faraday equal to 96,500. So 2 Faraday, you just times 2. So you get 193,000 column. Okay. Based on here, right, I know 193,000 column equivalent to 1 mole of copper solid will be formed. How about 2,700 column? So I'm using the stoichiometry method. So 2,700 times 1 divided by 193,000, I will get 0.01399 mole copper. Since I know the number of mole, right? So now the question asks about mass. No problem. I just molar mass times moles. I will get the mass. Mass equal to molar mass times mole. So 63.5 times 0.01399 mole. Okay, here is gram per mole. So mole cancel off. Okay, I will get the mass, which is 0.888 grams. So this is final answer, 3 significant value. 3 significant value. Okay, so this is how to solve the question number 3. Okay, is there other method? Yeah. As long as the concept is the same, you apply the correct concept, right? You will still get the same answer. So you check for this one. This one, right, this student, okay, yeah, Q equal to IT fixed. Okay, so what we know, right? 1 mole of electron equal to 1 Faraday equal to 96,500 coulomb. So this student go to check the number of electron passed through. Okay, so the answer is 0.028 mole of electron passed through. So based on here, right? Okay, 2 electron produce 1 mole copper. Okay, and then 0.028 mole of electron equivalent to 0.014 mole copper. Okay, so you see, right? Even though the method that I applied just now is different, but the concept is the same. As long as tally, no problem. So from 0.014 mole times molar mass, you still will get the same answer, which is 0.889 gram. Okay, yeah? So the method is the same. Based on this equation, right, we can know many things. 2 mole electron equal to 1 mole of copper. Okay, 2 mole of electron can form 1 mole of copper. So 2 electron actually is equivalent to 2 Faraday equal to 19300 coulomb. Also can, huh? Okay, I think that's all for today's lesson. So please stay tuned with us every Sunday, 3:30 to 4:30 p.m. Okay, please remember subscribe my channel and like, share this video. Thank you.
With God's grace, we are done with today's lesson. We have learned a lot from Teacher Kong on thermochemistry and electrochemistry. Congratulations to those who are able to follow our sessions from the beginning till the end. And thank you very much to Teacher Kong for such an interesting lesson. Before I provide the certificate link, let me give you the last two passcode, which are 4646. Okay, now please off the live chat button and click subscribe button if you haven't. This is to show your appreciations to Teacher Kong for giving you a free lesson today. Don't forget to also click the bell button so that you won't miss any new videos and live classes from Teacher Kong. If you like today's class, please click like and share it to your social media friends. Let's share the knowledge you received today. Sharing is caring, right? When you have finished, type down in the chat section and I will give you the certificate link. Once again, I would like to thank Teacher Kong for such an interesting lesson. Thank you also to Teacher Bibi Lau and Cikgu Mawar for being with us today. I think that's all for now. See you all in another session. Goodbye, everyone. Have a nice weekend.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.